All right, welcome. In this video, we are going to continue working with our import functions in tidyverse using the reader package. We're mainly working with importing CSV files, so we're going to be working with the read underscore CSV function. We're going to pretty much stick with reader from here on out rather than use the base R functions read.csv. So rather than do everything two ways in this function using base R and using reader, we're just going to really focus on using reader because it is a more efficient way of importing data. So let's talk about the column types that get assigned when we import data. So when we import a CSV file, recall the previous example with the students' data, some of the columns when they were imported as decimals, as double, some as characters. So the question is, how does the reader package, the read function, the read underscore CSV function, how does it determine what data type to use for different columns of the CSV file? So here's the heuristic that it goes through in determining what column type to use. If the column contains only F, T, false, true, whether they're written in all caps, all lowercase, some caps, and some lowercase, it's going to treat it as a logical. So it's flexible. It's not forcing it to be false in all caps or true in all caps. So even if someone makes a data entry error, what we would consider an error, entering F for false, T for true, which is not coded correctly, when you import it, it's going to convert it to a logical and read it as false and true. So that's the first thing it does. Okay, first it checks to see whether it's logical. If it is, it's going to assign it logical. If it's not, the next thing it does is it say, hey, does the column contain only numbers? If so, it's going to set it as the numeric variable of double type. So it's going to save it as a decimal rather than an integer by default. So it is not going to import any numeric variable as an integer, even if they're all integers. And it really doesn't matter all that much for R whether something is stored as an integer or a decimal. So you can always change it to an integer if that's what you prefer after the fact. Okay, now maybe your data is not a logical, maybe it's not a numeric. The next thing it's going to do, it's going to check to see whether it is a date. We haven't dealt with any date variables yet, but know they exist out there in the wild. And this will check to see whether all of the entries in a column are formatted as a date. Then it's going to read that column as a date format. Otherwise, if it doesn't fit a logical number or a date, it's going to import it as a character string. So the only four data types that are going to be possible when you import from the read underscore CSV is that your column is either going to be treated as a logical, as a double, as a date, or as a character. That's it. So those are the four possibilities. There are other column types that exist, such as factors and integers and other things. And if you want to use those column types, you'll have to manually adjust those. So the only four column types that you might get just doing a basic import is going to be logical, double, date, or string or character in that order. So if we're looking at this code cell down below, one thing that's nice with read underscore CSV is that we can actually just enter a comma separated file inside of quotes and it will import it that way. So here's some comma separated stuff that's equivalent to the table up above. So this first column the true, false, even though it's written in lowercase letters, and then the true that's just written with the letter capital T, it's going to realize you probably meant to enter false in all caps and you meant to enter true in all caps. So that first column, it's going to be transformed when we import it into logicals. The next column is all numerics, including the infinity. So it knows to treat the string I and F, not as a character, a string of characters, but as the kind of number, if you think about infinity as a number, but it treats it as the concept of infinity, which is a numeric. Here, all three of these are dates that it's going to treat as a date field, as a date data type. And then lastly, this last column that has A, B, C, D, E, F, G, H, I, it's going to say, hey, it's not a logical, it's not a numeric, it's not a date. So therefore, I'm going to treat it as a string. And we can check that. Let's run this code cell. You can see here, the first one was imported. We have one string, one numeric, one logical, and one date. And we can see what each of those are down below. So not only did it treat that first column as a logical, it converted the lowercase false correctly into the all caps false. It created the capital T, which is not how we should encode the logical true, into all caps true, which is how we encode the logical true. And these other columns, they were all fine. This is being treated as a decimal, a date, and a character, as we might have thought. So that all looks good. It's worth kind of pointing out here, I said I wasn't going to talk about the base R functions, but if you try to do something like this in base R, it gives us an error. It's looking for a file. So the read.csv function is not as flexible. The first input needs to be a file. The read_csv, we could actually just type comma separated information directly into the function, and it will convert it into a data frame, or a tibble even at that. Okay, so that is a wrap for the kind of heuristic that is used when we import a CSV file using read_CSV. Now you have some sense about what's the logic that goes on in determining what data type each of the columns is going to be formatted as. Okay, in the next video, we'll kind of continue on thinking about this some more. Thanks.